Let's calculate the mass density of the following gases at atmospheric pressure and room temperature. So before we start calculating, let's derive an equation relating the ideal gas law to the mass density rho. So we have the ideal gas equation, PV equals nRT. And we know that N equals the total mass divided by the molecular weight of the gas molecules. Now let's move total volume from the left side of the equation to the right, and we have mass divided by volume times RT, and then divided by the molecular weight. And we know that mass over volume is the definition of density, which is rho. So let's replace mass over volume with rho, and we have rho RT over molecular weight equals P. Now let's try to isolate rho on one side of the equation and the rest of the variables on the other side, and we have pressure times molecular weight divided by RT is the mass density of the gas. And now we know that in this question, the pressure is atmospheric, which is 1 bar. And we also know the temperature is room temperature, which is 25 degrees Celsius. So all we need to know is all we need to do is to find the molecular weight of the gas, and we'll be able to find the mass density of the gas. So for our first gas, it's nitrogen. We can find its molecular weight from either online or the appendix. To be aware that nitrogen is a diatomic gas, which means if you find the atomic mass number, you have to multiply it by 2 to find the molecular weight of nitrogen, which is 28. So the mass density of nitrogen is equals 1 bar times 28 grams per mole divided by 83.1447 centimeters cubed times bar over mole Kelvin, and then multiply it by temperature in Kelvin, which is 298, and we get 1.13 times 10 to the negative 3 gram per mole, gram per cubic centimeter. And then for oxygen, we will use the exact same equation, and the only thing that changes is the molecular weight. And here, the molecular weight of oxygen is 32. So again, same numbers for temperature, for pressure, and for ideal gas constant. So the mass density of oxygen in atmospheric pressure will be 1.29 times 10 to the negative 3rd gram per cubic centimeter. And we do the exact same thing for air. Here we will use the average molecular weight, which is 29 gram per cubic centimeter. And its mass density would be 1.17 times 10 to the negative 3rd gram per centimeter cube.